Okay, we are looking at chapter 7.7, inverse functions and relations. An inverse function we write as f to the negative 1. That negative 1 tells us it is the inverse function of f of x. One thing I also want you to realize is that f of x is the same thing as y, so we can use those interchangeably. Now we're looking at composition of inverse functions. Okay, so this is the inverse of f of x. Okay, we write it two different ways. So the first way, you have that open circle, or you can use parentheses instead. What I want you guys to see is if we take the inverse of the function of x, we get back in x. Same if we do it the opposite way. So if we take f of the inverse of the function of x, okay, we still can write it both ways, and we will still get out the original x value. So for an example, if I took the inverse of the function f and then put that into f, and I had an x value of 0.267, using our rule, we know we get back out that x. So our answer would just be 0.267. So I did it another way. If I took the function of the inverse of 6, I would still get out my x value, which was 6. Okay, next we want to find the inverse. So if we started with an equation y equals x squared minus 2, the first thing we want to do is switch our x and y values. Okay, so we switch the x and y. So now it becomes x equals y squared minus 2. So after we switch, then we want to solve for y. So the first thing to get y by itself is we need to add 2 to both sides. So we have x plus 2 equals y squared. The opposite of squaring something is to take the square root. So we take the square root of both sides, and whenever we take the square root, we have the positive and the negative of the square root of x plus 2, and that's going to equal y. So that would be the inverse of y equals x squared minus 2. Okay, example number 2, it's worded a little bit differently. It says, let f of x equal the square root of 2x plus 2, and we want to find the f of negative 1, which in the beginning we said f to the negative 1 is the inverse. Okay, so let's go ahead and rewrite it as y equals, because we have to switch x and y. So f of x in the beginning we said is the same thing as y, so we're going to change those out. So we have y equals the square root of 2x plus 2. Now remember, our next step is to switch our x and y. So we have x equals the square root of 2y plus 2. So to get rid of a square root, the opposite is to square. So we have x squared equals, and all we have left on that other side is what's underneath our radicals, so 2y plus 2. So to get that y by itself, first we have to get rid of that plus 2. So we subtract 2 to the other side. So we have x squared minus 2 equals 2y. Now we got to get rid of that 2 in front of our y. So we divide everything by 2, and we get x squared minus 2 divided by 2 equals y. Okay, number 3. We want to find the inverse for x squared plus 3 equals f of x. So again, realize f of x is our y, so when we switch x and y, we get y squared plus 3 equals x. Then again, we solve for y. First step is to subtract 3, so we get y squared equals x minus 3, and then we have to take the square root because we're undoing that squared. Whenever we take the square root, remember to add your plus or minus in front. So y equals plus or minus the square root of x minus 3. Number 4, it says let f of x equal 10 minus 3x. Part A wants us to find the inverse. Okay, so we go ahead and change out that f of x for a y. So we have y equals 10 minus 3x. We flip our x and y's, so we have x equals 10 minus 3y. Our next step is to go ahead and subtract that 10. So we have x minus 10 equals negative 3y. Then we got to divide by that negative 3. So it cancels over with our y. And we're going to move that negative on the bottom to out in front. So we have y equals the negative x minus 10 over 3. Part B of this problem, still with f of x equals 10 minus 3x, wants us to find the inverse of f of 3. Okay, remember back in the beginning we had those rules. If we took the inverse of a function, it's going to equal the x value. So the x value that we have right now is 3, so our answer is 3. Now we're looking at finding the inverse of a relation. Okay, so we have the relation m with the x coordinates as negative 1, 0, 1, and 2, and our y's being negative 2, negative 1, negative 1, and negative 2. Okay, so the same thing that we did with our functions, we have to switch our x's and our y's. So our new table, it would have our x values as negative 2, negative 1, and negative 2, and our y's would be negative 1, 0, 1, and 2. Okay, so that bottom one would be our answer. All we do is flip the x's and the y's.